Hi everyone, Dr. Stephen Hussey here from ResourceYourHealth.com. In this video we're going to discuss why we don't see atherosclerosis in veins and also why atherosclerosis is not widely dispersed throughout the arteries. We only see it in some places. Now I wrote a blog about this recently, so for all the details go there and check out that blog, but for this video I'm going to summarize the key points. So some background information before we answer this question. Dr. Gerald Pollack of the University of Washington has studied water, and he's found that water has the ability to hold energy. And when it holds energy and you put it next to a water-loving surface, it will form what's called exclusion zone water. So basically the water kind of restructures itself and forms this layer next to the hydrophilic surface. Now, interestingly, he found that happens in biological places. So he found it in like plant roots, but also in the lining of our arteries and blood vessels next to the endothelia. And so basically what happens is we get this, if we have a tube, which our arteries and veins are, and we have water, which nearly half our blood is water, and we have energy to the system, and we're supplying energy to that water, then we get this formation of this exclusion zone water next to the lining of our blood vessels. And so that'll go around the whole circumference of the blood vessel. And what it does is it creates, because of the way the exclusion zone forms and how it kind of cleaves water into two separate molecules, it's very negatively charged. So it's a very negatively charged area that's stacked up next to the lining of our arteries. And it's called exclusion zone because anything that's not that water will be excluded. Like nothing can get through. And Dr. Pollack said that nothing could get through. Like he scraped some dirt from outside his lab. He found the proteins. Nothing could get through. Nothing that was in our blood could get through to be touching the lining of our arteries. So it kind of serves as a protective barrier there. Now, there are things that we can do to increase the building of this structured water or this EZ water, and that is like being exposed to radiant light like the sun or infrared saunas, being in contact with the earth, so direct contact like grounding, things like that will help build this exclusion zone water. But there are also things that can break it down. And so we have talked a lot about in other blogs, oxidative stress. And oxidative stress is basically when we have free radical molecules that are made by the process of us making energy, or if we're exposed to toxins. When those things get to be too much because we're burning carbohydrates for fuel or we're exposed to too many toxins, then they can actually damage tissues. And they do this by stealing electrons. And since this exclusion zone water is so electrically negative, it has a lot of electrons to donate, and so it ends up getting damaged. And once the exclusion zone area gets damaged enough that the endothelial layer, the lining of the artery, is exposed, then that oxidative stress and inflamed environment that damaged the exclusion zone water is now damaging our arteries. Now, the question then becomes, why do we only see this damage and atherosclerotic buildup in arteries and not veins if the same process is happening in both? And so the reason is that the arteries are under a lot more pressure. And so because of that, the free radicals that may be floating around are pressed up against the lining of this exclusion zone water more forcefully. And so there's just more of a chance they're going to steal an electron and cause that damage. And so that's why we don't see atherosclerosis in veins, because they're not under much pressure. And we do see it in arteries because of the increased pressure. Now, why do we not see atherosclerosis widespread throughout the arteries? Well, that's because there's areas where there's increased pressure. So whenever an artery splits, that there's more pressure in that situation. Whenever the blood goes around a curve of an artery, like the aortic arch is a perfect example, then there's more pressure. The blood is kind of pushed up against the lining of the artery more forcefully, and there's more chance for it to break down, those free radicals to break down that exclusion zone water. But also the coronary arteries, the arteries in the heart, are under more pressure because of the pressure created by a heart that's constantly expanding and contracting. So they're under more pressure, so they're more likely to get atherosclerotic damage. So that's why we see atherosclerosis in veins and not arteries. But then the question becomes, why would, or I guess, what does LDL cholesterol increase the chances that we get atherosclerosis? And the answer is no. The oxidative stress is what causes the damage, and the cholesterol and minerals and things are deposited there kind of as a reaction to the body to patch up the damage, but they're not the cause. And I've written about how high cholesterol is actually beneficial and other blog posts, so check those out too. All right, so if you found this helpful and interesting, please like and share it wherever you can. Otherwise, that's it for now. Stay healthy out there.